I am Dr. Senthilkumar, Professor in ECE Department, B.SB Engineering College, Karur. Today I am going to talk about Boolean algebra, which is used in digital system design. So now we are going to talk about the introduction for Boolean algebra. So this is about introduction for Boolean algebra. Actually it is developed by English mathematician George Boole in between 1815-1864. It is described as a algebra for logic or an algebra of two values in true or false, or else it can be 1 or 0. The term logic means a statement having binary decision, either it can be true or false. Now come to the application of Boolean algebra. So this is about application of Boolean algebra. Actually it is used to perform the logical operation in digital computer. As you know that the electronics can be categorized in two ways. One is analog electronics, another one is digital electronics. In the digital electronics we are going to talk about these areas. So in that the ultimate requirement of digital electronics or digital system design is we have to develop a efficient system that should perform operation on digital data. Normally the digitals are binary values, it is zeros and ones. So accordingly we are going to talk about the Boolean algebra. Especially it is used to design the efficient digital systems. That means we have to have a compact design in the design of digital system. Also we have to have a minimized number of gates so that we can reduce the power consumption, the efficiency can be improved, speed can be improved, and as well as the delay can be improved. Okay, for that we are going to have this Boolean algebra. Okay, so in that Boolean algebra there are major three logical operations. One is AND, another one is OR, another one is NOT. So now come to the AND operator. So in that you assume that there are two inputs to the gate. Okay, the AND operator can be relevant to AND gate also. In that AND gate you can think about there are two inputs, one output. Okay, so this can be one input, this can be another input. Namely x is one input, y is another output. The expected output should be x dot y. Okay, so in that you can supply, as we discussed earlier, that can be either 0 or 1 in the input side. Since it is a digital system, we are talking about digital system design. In that we will be talking about only binary values in the name of zeros and ones. Here x may have 0 as well as 1. Sometimes y may have 0 or 1. So in that expected AND operator is if x is 0, y is 0, the output should be 0. Similarly, you look at here, when x is 1 and y is 1, the output should be 1. So if the outputs are different, there are only two possibilities of inputs, either it can be 0 or it can be 1. If two inputs are different, you will have 0 here. If here, if 0, 0 is there, 0 will come. If 1, 1 is there, 1 will come. So this is about the overall operation of AND operator expected as per the Boolean algebra. Now come to OR operation. So now this is about OR operator, and this is also one kind of another basic logic gate. In that again you will have two inputs in the name of x and y. The expected output should be x plus y. Okay, so this is a logical operator, logical plus a sum operator. In that here also you see here also 0 is provided, and y in y there is 0. Similarly in one x can be 1, y can be 1. Look at this is the all possible combination for two input OR gate. Okay, so here if 0, 0 is there, you can get 0 as the output. If 0, 1 is there, you will get the 1 as output. If x is 1, y is 0, then you will get 1. So if both are 1, again you will get 1. Here what you have to understand is, if both inputs are 0, then only you will have a 0 as the output. Otherwise, in all possible combination, you will get 1 as the output. Okay, this is about OR operator involved in Boolean algebra. Now come to NOT operator. So in that NOT operator, actually look at the word they are specially used here. It is not is nothing but complement. So here there will be only one input, for that there will be only one output. Okay. So here since there is only one input, it is named as X. We can choose our own label for the input. Here it is, they have considered it as a X for input. So if X is 0, then the output, expected output to be 1. If X is 1, the expected output should be 0. Look at the symbol here. So this is to indicate the complement. Okay. So if suppose if you have used Y, then automatically here it becomes Y bar. Okay, you can say it is bar also, or you can mention it as a complement. Okay, so this way it will work out. So the NOT operator, it is expected that if input is 0, output is 1. If input is 1, the output is 0. Okay, it is the complement value. Okay. So now come to the concept of truth table. So normally the truth table is constructed with the help of again the binary values. Normally the truth tables are used to describe about the function of the particular system that we want to design. Okay. Now you look at here, this is the definition for truth table. The truth table is a table that contains all possible values of the logic variable statement in a Boolean expression. See, for example, the meaning of all possible values in the sense, as we discussed already, if there is only one input, then the number of possible combinations are either 0 or 1. That is 2 power 1. There are two possibilities of input, that is either 0 or 1. Similarly, in the case of, as we discussed in the previous cases, if AND gate is, there are two input AND gate or two input OR gate, there are two possibilities of input, either X or Y. Okay, in that case, 2 power 2, there are 4 possible inputs, 0, 0, 0, 1, 1, 0, 1, 1. So this is the meaning of providing all possible values. Okay, suppose if there are 3 inputs, you will have 2 power 3 is equal to 8 different possible variables that we will see in the next classes. Okay, now look at this. As I told already, the number of possible combinations of inputs, okay, equal to 2 power n, where n is equal to number of variables used in a Boolean expression. Okay, so this is about this. Now come to here. So this is to describe about the combination of Boolean expression output. Okay, so either you can have one, as we discussed already. So the output either 1 or 0. Okay, accordingly the statements are given here. So apart from this, the truth table can be like this also. So in the earlier cases, we discussed about only 3 varieties. Either there were AND gate, OR gate, and NOT gate. Apart from this, there can be a combination like this also. Look at here, that here the output required to be all possible things. Like this is the AND operator, this is OR operator. By this combination also, we can have a Boolean algebra expression like this. Okay. Now you look at this here, X, Y, Z can be the possible inputs to the logic gates. So since there are 3 possible inputs, as we discussed in the formula earlier, there are 2 power 3 is equal to 8 possible combination. Here it is mentioned. Look at this. This is the equivalent decimal value. For example, if decimal is considered, the equivalent binary values are 0, 0, 0. If decimal value is considered 1, the equivalent binary values are 0, 0, 1. If it is 2, then 0, 1, 0. It goes like this. Finally, it goes 7 is equal to 1, 1, 1. See, accordingly, X into Y, as per we discussed earlier. So XY will be 1, then Z 1 plus 1 is equal to 1. For to identify the final column, you have to think about the concept that we already illustrated there for the operation of OR gate and gate. Okay. So now you can see here where you can apply the Boolean algebra. Normally we are very familiar with the computers nowadays, as you are aware that the computers are one kind of digital system. So the Boolean algebra can be applied in the designing of efficient computer models. Okay. Now we come to the detailed concept of AND gate. Okay. So now look at here. This is the logic symbol for AND gate. As we discussed already, there are 2 inputs. Earlier we had X, Y. Now it is A, B. So the label can be fixed by the designer or user. Okay. According to our requirement, according to our desire, we can design or put our own label. So there is no restriction to put the label. So it can be anything. So here it is mentioned A and B. The output is AB. Okay. So it is AND operator. So that can be AB. So look at the truth table. So this concept is called truth table. As we discussed already, since there are two inputs, there will be the possibility of four combinations. Possible combinations like 0, 0. Look at this. 0, 0 in the sense A can be 0, B can be 0. So accordingly, as we discussed earlier, as per Boolean algebra, AB is equal to 0. Now if A is 0, B is 1, then output should be 0. If input is 1, for A 1, B it is 0, then output should be 0. If both are 1, then the output will be 1. So what you have to finally understand is, if both inputs are 1, the output will be 1. Otherwise, the output will be 0. So this is the case. This is the symbolic representation of AND gate. Now come to OR gate. Okay, so this is the symbolic representation of OR gate. Look at the way how it has been done. This is very much important. See, for again the reference, I am showing this. See, look at the shape given here. So this L shape is very much important to make a difference between AND gate and OR gate. Okay, so here the shape is like this for AND gate. So this is the symbolic representation of OR gate. So this is the end symbol, how it should be, you should know. Okay, now you look at here for OR gate, this is the expected truth table. Again, since there are two inputs here, A and B, and the inputs are mentioned here, this is the structure of truth table for this particular OR gate. Okay, so for this is A plus B, this is shown in the output. Okay, so this is the OR operator, logical operator, binary operator as per the Boolean algebra. Now if A is 0, B is 0, the output should be 0. For all other cases, as we discussed already, since this is there are two inputs here, you will have four possible combinations like this: 0, 0, 0, 1, 1, 0, 1, 1. See, this is constant for all the cases of digital system. Okay. So if this is the case, if 0, 0 only, you will have a 0. For all other combination, you will have a 1. Okay. So that point you should note as per Boolean algebra for OR gate is concerned. Now come to the NOT gate. So this is about NOT gate. Look at the symbols. See here, unlike in previous cases, here you can see a bubble. So this will be the triangular shape. So in that, at the end there will be the circle there. Okay. So this is the symbolic representation of NOT gate. So as we discussed already, there will be only one input, only one output. So look at the bar here. So it shows the output for the corresponding gate. Okay, so this is the simple truth table for the NOT gate. So here, since there is only one input, there are two possible combinations only, either 0 or 1. 2 power 1 is equal to 2 as per the formula we already discussed. Okay, now the input is 0, the output is 1. Look at the symbolic representation. Here it is mentioned as A bar, it is the complement of A. So if input is 0, the output is 1. If input is 1, the output is 0. So this is the simple information about the NOT gate implementation. Now look at here, this is one of the real-time example how the AND gate can be used. Look at here. See, assume the situation that you are going out from the home. So in that case, while leaving, you are putting one switch is on. So the information provided here is you are out of the home. Now if any person is coming in, any intruder like this, if coming in, the another switch will open or on, switched on. Okay, so in that case already you went out putting the switch on, so that is one. If this person is coming in, again the switch will, another switch, incoming switch will come to 1. So 1.1. Now look at the example for OR gate. Okay. Now assume that there is a calling bell available in the home. It can be operated by either front door or back door. Okay. So in both cases it can be operated. So if you are pressing the switch at one end, and that can be considered as 1, in some other end it has been switched off. So that is 0. So either cases we want to operate the bell to be ring. Okay, if the bell is ringing, you can assume it is a 1. If one side of the door is door switch is pressed, you can consider that as 1. If front door is pressed, switch is pressed, you consider that as 1. Then that back door switch is off, that is 0 in both cases. Otherwise, another case is if that back door is pressed, that is considered as 1. If front door is closed, that not pressed, that is you can consider 0. So either cases, if that is pressed, that is 1 0. If this is pressed, it is 1 0. So either cases we want to make a alarm to be ring. Okay, that case you can consider as 1. If alarm is ringing, that you can consider as 1. So 1 0, alarm ringing 1, 1 0, alarm is ringing 1. Okay, that is the case for OR gate. Okay, now come to the application of NOT gate. Okay, now look at here. So if the temperature below 20 degrees centigrade, we want to make an alarming on. So either it can be alarming or you want to switch on the any heating mechanism. Okay, that can be considered. If the temperature is above the 20 degrees centigrade, assume that if we assume that if the temperature is 20 degrees centigrade, above the 20 degrees centigrade, we don't want any heating mechanism. Okay, if the temperature becomes below the 20 degrees centigrade, we may feel shivering. At that time, we want to switch on the heating mechanism. Now, there can be the effective detection mechanism so that whether the temperature is either above 20 degrees centigrade or below 20 degrees centigrade. If you want to make, if the heating is switched on, you assume that it is 1. Okay, in that case, if we have to put the effective mechanism, if 20 degrees centigrade, the input is 20, above the 20 degrees centigrade, the input should go 0. So accordingly, it should 1. Okay, so that way you have to consider the operation of the NOT gate. Okay, so here only single operation. What you have to think is only one single operation that we want to make use of it. Okay, so in that case, that is if temperature is low, then we have to switch on the heat. If temperature is normal cases are above the requirement at the same place, then you need not to switch on the heating mechanism. So this is the only one circumstance operation is required. So in that case you can go with the NOT gate operations. Okay, with that we close the basic gates operation used in Boolean algebra. Thank you.